Hello students! In this lesson, we will discuss about on how to name our carboxylic acids, what is its general formula, how it differs from an aldehyde, some of its common names, and how do we give it a name in alignment with our IUPAC nomenclature standards. But before we proceed, stay tuned as I'll be revealing the answer to our pretest after the discussion. So, based on your prior knowledge, can you guess the name of this carboxylic acid? Carboxylic acid is a functional group in organic chemistry that has a general formula of RCOOH with a suffix of oic acid. So that's one way of identifying a carboxylic acid. So in comparison to an aldehyde, they both have a carbonyl group, that's a carbon double bonded to an oxygen in their first carbon, but unlike aldehyde, our carboxylic acid has a hydroxyl group attached to its first carbon or an OH group in comparison to our aldehyde, which only has a hydrogen attached to its first carbon. So carboxylic acid has a common name and an IUPAC name, but for this lesson we will solely focus on the IUPAC naming for our carboxylic acid. And here's the first example. So we have here an organic compound that has at least 4 carbon-to-carbon bonds, and this specific carboxylic acid is named butanoic acid. So let's get to know on how do we derive with a specific name for a carboxylic acid. So naming carboxylic acid is just the same with naming other functional groups in organic chemistry. We use the same format. We have here highlighted in the yellow color. So that's the same format that we use, but the only difference is that we have the suffix of oic acid. So let's get another example to apply these rules that we'll be following in naming for the IUPAC nomenclature of carboxylic acid. So here is an example of our carboxylic acid, and let's get to name this organic compound. So first things first, let's identify the parent chain by counting the number of carbon-to-carbon bonds. So in this case, we have 6 carbon-to-carbon bonds, and we can't see any double or triple bond, so this parent chain is named hexane. Second thing, let's identify any substituents or branches. So in this case, we have a branch on the second carbon, and that's an ethyl group on a second carbon, so we name it 2-ethyl. So now that we have our parent chain and our substituents, it's now time for us to combine these variables. So we have 2-ethyl plus the parent chain of hexane plus the suffix of oic acid. Then we have our carboxylic acid name, which is 2-ethyl hexanoic acid. It's just easy, right? Let's get another example. So in this case, first things first, let's count on the number of carbon-to-carbon bonds to identify our parent chain. And in this carboxylic acid, we have 8 carbon-to-carbon bonds, and we can see any double or triple bond between carbon-to-carbon, so the name of this parent chain is an octane. Now that we have our parent chain, let's identify its branches or substituents, and there we go. We have it on the third and on the fourth carbon, and respectively, the one on the third is an ethyl group. We name it 3-ethyl. And the one on the fourth carbon is only a methyl, and we give it the name of 4-methyl. Now that we have our variables, it's now time for us to arrange them alphabetically to get the name of our carboxylic acid. So remember, in arranging this alphabetically, we have our ethyl first, since letter E comes before letter M. So that's 3-ethyl plus the 4-methyl plus the parent chain octane plus the suffix of oic acid. And here we have it. Our carboxylic acid name is 3-ethyl 4-methyl octanoic acid. It's just easy, right? Let's have one more and let's try to complicate things a bit to give it a more challenge. So our next example, as we can see, we now have a double bond. So how are we going to name this? So let's just follow those simple steps. So first, identify the parent chain. And we have 7 carbon-to-carbon bonds with a double bond on the second carbon. So the name of this parent chain is hept-2-ene to specify the location of the alkene on the specific parent chain. Next, let's identify the branches or substituents of this carboxylic acid. And there we have it. We have them on the third, fourth, and sixth, respectively. The one on the third carbon is an ethyl group. The one on the fourth and the sixth are both methyl group. So to give it a name, the one on the third is a 3-ethyl. The one on the fourth and sixth, since they are both methyl group, we just combine them, 4 and 6 dimethyl. So it's a di to represent there are 2 methyl present in this specific carbons. So now that we have our variables, it's now time for us to combine them to have our carboxylic acid name. But in naming this, we have to arrange them alphabetically. In this case, we have ethyl coming in first, but why? Di, letter D, comes in first before letter E. So take note of this, guys. In naming alphabetically in any IUPAC nomenclature for functional group, we have to take note of the base branch, not its prefixes. So in this case, we still have E coming in first before M for the methyl. So we have 3-ethyl plus the 4 and 6 dimethyl, since there are 2 methyl group in separate 4th and 6th carbon, plus the parent chain of hept-2-ene, plus the suffix of oic acid, and there we have it. The name of our carboxylic acid is 3-ethyl 4,6-dimethyl hept-2-enoic acid. So it's in since it's an alkene, so that's why it's an enoic acid. And the number 2 represents the location of the double bond. Alright? So it's just easy, right? Getting to know on how to derive with the IUPAC nomenclature of different functional groups is just the same process with different suffixes. And in this case, for our carboxylic acid, we just add the oic acid for our suffix. Alright, guys, so thank you for staying till the end of this lesson. I will now reveal the answer to our pretest earlier. So the answer to this pretest, this specific carboxylic acid are named. The first one is a 4-methyl octanoic acid, since it's an alkane with 8 carbon-to-carbon bonds, and that's the parent chain with a methyl group in the 4th carbon. And the second one, that is a 3-ethyl hexanoic acid, since we have hexane as its parent chain and an ethyl group attached on the 3rd carbon. Alright, so thank you for staying, and as usual, I've attached in the description link down below the link to the PowerPoint presentation that I've used in this discussion, so you can study your organic chemistry lessons at your own pace. Alright, thank you for staying with me, students, and I'll catch you on the next one.